Lamborghini introduced the new V8 engine that will push the heir of the Huracan. And guys, it's crazy, truly impressive. Listen this, it will be able to rev up to 10,000 RPM. I believe I am not aware of any other turbocharged engine able to rev so high. But let's take it slow, let's start from the beginning and I'll tell you everything we currently know about this engine. First of all, I'm Andrea, I'm an Italian engineer and I make videos about the most technical aspect of the automotive world. I just decided to start this new English channel because, you know, Italy is a small country, we are very few people, so I hope that making English video I will reach a much wider audience and who knows, maybe one day this will allow me to buy a Lamborghini. So, if you like cars, if you like my strong Italian accent, if you like the fact that I'm not able to speak keeping my hands still, please subscribe and show some love with a like. But let's start with this new Lamborghini engine. 8 cylinders in a V configuration, 4 liters displacement, quite standard, it's the same displacement of Ferrari's V8s and McLaren V8s for example. And the first characteristic that Lamborghini stresses in this presentation is that the crankshaft will be flat plane. Just to explain this briefly, American V8s are mostly cross plane, which means the crankshaft is basically like a cross, with the pins spaced 90 degrees between one and the other. While in a flat plane, as the name suggests, all the pins are on the same plane. It's flat. And this is more common on racing engines, but also on high-performance road-legal V8 engines like, for example, Ferrari engines. Because with a flat crankshaft you need less counterweight. This means that the crankshaft itself is lighter and so it can spin faster. So in other words, this allows the engine to rev higher. And as we will see also with the other characteristics, this engine is purely designed to rev high. And another beautiful consequence of the flat plane crankshaft is that you have this smooth, round sound typical of Ferrari V8 engines. Very different from the typical American V8, which is more rough. Because with a flat plane you have the combustion evenly spaced, one on the side and the next on the other side of the engine. While with the cross plane, during the cycle of the engine, at a certain point you have 2 combustion on the same side of the engine. This means that the pressure wave on the exhaust will sum up and you have this more sound typical of American V8s. Next to the second feature of this new engine, connecting rods will be made in titanium. Titanium is much lighter compared to steel, but at the same time is way stronger than, for example, aluminum. And this perfect balance between strength and lightness again will allow this engine to rev so high, while at the same time being able to withstand the pressure and the stresses typical of a turbocharged engine. Another very delicate aspect of an engine revving so high is valve timing, because when you're at like 9,000, 10,000 RPM, valves have to move so quickly up and down that they risk not being able to close completely. So Lamborghini chose to have the so-called finger follower, which is a valve actuation system much stiffer and much more precise than the more common bucket and shim. Then moving to what actually delivers power, as I told you at the beginning, this will be a turbocharged engine. And the 2 turbochargers will be allocated inside the V of the engine, in the so-called hot V configuration, which is becoming quite common in high-performance turbocharged engines. For example, Ferrari uses this configuration in the V6 of the 296, McLaren uses this configuration, Mercedes uses this configuration for their V8 AMG engines, because having the turbochargers up there, first of all, gives you a more compact engine, because you don't have turbochargers on the side, because you move the turbochargers from the side to the inside. Moreover, you gain much better thermal management, because as you know, heat naturally tends to go up. So if the hottest parts of the engine are already above, it's much easier to keep a lower temperature on the rest of the engine and to expel all the heat above. Moreover, also the flux of the gases is easier, because you basically have shorter ducts. And then once you have push all this air inside the engine, of course you need gasoline. And here comes the 350 bar direct injection system. Direct injection is basically mandatory on turbocharged engines because as you compress all this air, you increase temperature. And when you have high temperatures inside the engine, you risk knock. Direct injection helps reducing the risk of knock because you can add gasoline just at the end of the compression stroke. And of course, as you are spraying gasoline directly inside the cylinder, you also have a much more precise control of how much gasoline actually takes part in the combustion. This, as you can imagine, is very important to reduce emissions and to reduce fuel consumption. And that's why direct injection has become the standard for most engines. What's not so standard is having direct injection for an engine revving so high. Normally, if you want an engine to rev fast, you'd prefer port injection because it allows gasoline to mix much better with air and then combustion is faster. For example, Lamborghini V12 engine has port injection and many racing engines use port injection as well. Some high-performance engines can also combine port injection and direct injection to manage both low speeds and high speeds. Other car makers invented other solutions like pre-combustion chamber introduced by Maserati, which again is needed to make combustion faster. Seeing just direct injection for an engine able to rev 10,000 RPM is almost confusing to me. I'm really curious to see if Lamborghini will later reveal any details about how they can manage this. Next up we have lubrication, which of course is dry sump lubrication, which is the standard for high performance engine because it allows to have perfect lubrication even under high lateral accelerations, which will make the common oil pump basically useless, as you would have oil sloshing around with the pump unable to suck it. With dry sump you always have perfect lubrication and at the same time you remove the oil pump so you can lower the engine, lowering the center of gravity of the car. Two different benefits which of course are very important if you want your car to go fast. Another very peculiar detail which is not stated anywhere but I noticed it from the images of the engine is that many parts have these marks on them which are typical of 3D printed parts. So I'm guessing whether they have been produced directly through metal 3D printing or if 3D printing was used to produce sand molds on which then the metal was casted. Because yes, you can 3D print sands to make casting molds. It is becoming quite common, for example, for pre-series production when you want to have your parts quickly without needing to produce all the definitive molds. I'm really curious to see if this is true only for this pre-series engine or if it will remain also in the true production. Because even in that case, 3D printing mold sands can have strong advantages in terms of complexity of geometry. But moving away from my material engineering thinking, let's see the numbers of this engine. 730 Newton meters of torque, available between 4,000 and 7,000 RPM, and a maximum power of 800 horsepower between 9,000 and 9,750 RPM, with the red line up at 10,000 RPM. Again, as I told at the beginning, this is crazy for a turbocharged engine. If you remember any street legal engine able of this, please write it in the comment, because I'm pretty sure this is a world record. But if the maximum torque is at 4,000 RPM, what happens before that? Is the engine dead? No. Here comes into play the electric part, because this is a hybrid powertrain. So there will be an axial flux electric motor, basically in line with the crankshaft of the engine, so mounted between the engine itself and the gearbox, which by the way is a dual clutch 8-speed gearbox mounted transversely. And this electric motor will add 150 horsepower and 300 Newton meters of torque, available up to 3,500 RPM. So right there covering the weak point of the internal combustion engine. And this is a different choice compared to what Lamborghini did with their Revuelto, where the electric motor is inside the gearbox. Quite interesting difference. I'm curious to see how this will translate in terms of performance. And then, like in the Revuelto, there will be two more electric motors at the front, but we don't know their specs yet. So for now we can only guess how much the total power will be. The Revuelto internal combustion engine has 825 horsepower. Here we have just 800, so 25 less. The combined power of the Revuelto is 1015 horsepower, so I'm guessing with this new V8 we will be something around 900 something. I think it will remain below 1000, otherwise it would be too close to the Revuelto and it wouldn't make so much sense. Also because this new V8 car will be, I think, lighter than the Revuelto, as it has a more compact engine. It will be probably smaller in terms of external dimensions. So with these power figures, with the aid of the turbocharger, I think the performance of this new Lamborghini will be very, very interesting. So let me know what you think about this in the comments. I hope you understood at least 90% of what I said. I hope in the next videos it will become easier and easier for me to speak in English. Again, if you liked it, please show your support and see you in the next videos. Ciao!